Radar's electronic eyes watch the skies and report what they see to SAGE, Defense System of the United States Air Force. Here is a SAGE center on 24-hour alert. At its heart is a computer developed by a research team from MIT and IBM working with the Air Force. The SAGE computer speeds the information for decisions by man in our missile age. Every scheduled flight across American frontiers is recorded ahead of time on IBM punch cards, then fed into the SAGE computer. Now the computer can draw a picture of what is supposed to be in the sky at any moment. It continually compares this expected picture with the real picture as seen by radar. If a flying object does not belong, it appears on this viewing screen. There's one now at the right of the screen. They call it a blip, unknown flying object. Friend or foe? Within seconds, the Air Force will know. The officer fires a light gun at the target blip. This tells the computer to track the object. At the launching site, a
Check.
long-range Beaumark missile is ready
That's
for
me.
firing. Now they ask the computer to calculate an intercept point. X marks the spot where the Beaumark missile would meet the moving target if fired immediately. The officer in charge makes the final decision. Fire. At the moment of launching, the Beaumark missile receives instructions from the IBM computer. As the missile screams toward target, radar keeps on tracking. With electronic control, the computer automatically adjusts the missile to meet any change in the target's flight. There is no escape. Intercept. This was a test, one of many successful tests of the SAGE Beaumark security team, our new system of air defense. To be ready for the worst, so that the worst will never happen, America is now armed with instant electronic reflexes.
Hello. This is part 2 of ground stop anomalies live coding. I'm John. And hopefully my kids will stay in their bedroom while I'm trying to do this. This is part 2. Amy's out having dinner with some friends. And the kids have not been wanting to go to sleep, but I think they're finally asleep. So I thought, oh, I'm going to stream. Well, I thought I'm going to write some code. And okay, I'll stream it. And so, what are we streaming today? The code I want to write. Okay, so just to recap a little bit from part 1. Last Monday, January 10th, there was a nearly unprecedented multi-region ground stop issued by the FAA, which meant that they weren't letting planes take off, and they were telling planes that were in the air that they had to land, saying things like, we might have to scramble fighters, which I don't think was true. They just didn't know what they were just speculating, but that's the kind of chaos and confusion that was going on. And it wasn't helped by the fact that the way the FAA did this, and we don't know why this happened yet, but they said, ground stop, all departures now. And then they said, nope, resume normal operations. Sorry about that. I'm trying to delete it. Wait, no, stop all departures again. No, this is not a joke. Okay, yeah, the ground stop is canceled. Back to normal. And all that happened within just like at most 10 or 15 minutes. And the reason apparently was because of the North Korean missile test that happened at the same time. And that's about all we know about it. But the code I'm going to write was inspired by a friend pointed this out to me. At LAX around the time of the ground stop. I mean, I don't know if, because it sort of, there was a stop and go. I guess this must have been during a go portion. But this shows over here, there's a United Airlines passenger jet taking off from runway 25 right at LAX. Meanwhile, there's this other small plane on the taxiway. And what's going to happen is basically United Airlines jet tried to take off, and as they were taking off, the small plane turned onto the runway, got in their way. The passenger jet had to slam on the brakes, abort the takeoff, reject their takeoff. And this is a little
Wingspan 5, verify hold short, runway 25 right stop, please.
16, rejecting on the runway.
So you hear the United pilot saying, rejecting on the runway, because the small plane is in the way. And maybe it's just a coincidence that this happened at the time of the ground stop, but it made me wonder if maybe the chaos and confusion, the increased workload, the distraction might have contributed. So nothing really serious happened here. The passenger jet just turned off the runway, got back in line. They had to wait about 15 minutes, I guess, just for their brakes to cool down before they could take off again, because they got up to at least 60. I think I saw a data point at 64 knots before hitting the brakes.
For United 566, make it official. Cancel your takeoff clearance, American, the right turn in Bravo 2, the right turn back on the Bravo.
So whatever happened, I just wondered if maybe more of this happened around that same time. And I thought that it should be possible to actually look at that using ADSB Exchange historical data. Someone sent me that data so the ground stop happened over the entire West Coast. I just got paranoid that maybe I forgot to set something up. For part one of the stream, I forgot to turn on the camera for the first 10 minutes. I think everything's set. So the ground stop was the entire West Coast and Hawaii. And I guess that hasn't happened. They haven't had a multi-region ground stop like that since 9/11. So I want to write some code that would look at that historical data and just look for other rejected takeoffs, or maybe other things too. Maybe we can look at rejected or aborted landings, go-arounds. And so what we did in part one, wrote the beginning of a Rust program that parses this GeoJSON data. I'll show you what the data looks like. GeoJSON format. It's just I think it's one big feature collection. A lot of points. The points have properties. An important property is the hex. That's the unique ID for the aircraft. Barometric altitude in feet, I assume. GS ground speed, and TS timestamp. So last time we got to the point of loading and parsing that file, basically. Let's see if it currently runs. I haven't opened this since last time. Okay. Oh, really? I thought we fixed this before. That's weird. Oh. So those, that gray text, that's a GitHub autopilot or Copilot suggestion. That's the neural model that I love. Sometimes seems almost psychic. I don't know if that's the right version. That's probably something it's not very good at. Is selecting the exact right latest version. So we're just pulling in SAR-JSON. Because, so currently there's barely any code here. We open the data file, read it, parse it as GeoJSON using the GeoJSON crate. And then we call this process GeoJSON function, which just looks in that giant feature collection, iterates over all the features, looks for the points. Is it a geometry? extract the coordinates from the point using point coords. So we pull out longitude and latitude. Pull out the hex or IKO address, the unique identifier for the plane. If there is an altitude property associated with that point, then this is if there isn't, just skip it. Because right now, so to look for rejected, we're just going to start by looking for rejected takeoffs. And we're just going to do a simple thing to start out, which is look for anyone on the ground. Someone on the ground that's accelerating, and then their speed exceeds some threshold, like, I don't know, 50 knots or something, which, you know, they're not just taxiing. And then maybe we'll look for, you know, someone that does that and then decelerates and does not take off. Something like that. So if there's no altitude, skip it. Otherwise, parse it. Yeah. Otherwise, extract. So the alt-barrow property can be either a string, like ground, or it can be a number. So we call parse alt on whatever it is, which is a surd JSON value. And this is some leftover old code when it is a different type. So let's get rid of that. And let's let Rust Analyzer fill in all the stuff. So it's going to be either a number, and that's the GitHub Copilot suggestion. That's what we want. If it's a number, we just want it as a float. In this, right now for this code, we're not doing any good error handling. If it's not what we expect, just panic. That's what unwrap does. And if it's a string, if it's a string, no, that's not what we want. Let's make it 0. If it's anything else, we don't care about all this other stuff. If it's anything else, yeah, unexpected thingy, exactly. Thank you, Copilot. So it, you know, it took that because that's what I did up here. So it's got a model, but it also, you know, it's like it's using the rest of my code as a prompt or something. That looks about right. It doesn't look like we have any errors. Let's just see what happens if we run this. So right now at the moment, I think all it does is print. Yeah, it just kind of print stuff. While it's building, there we go, just testing the chat window. I love GitHub Copilot. I never want to program without it. Maybe my programming style is a good fit. I'm kind of a slapdash programmer who kind of just writes code and tries to bang it into submission and make it work. I don't think about it at a time that much. So maybe Copilot wouldn't be great for everybody, but I would hate to program without it at this point. Okay. Ran it, it panicked. Yeah, okay, so the same sort of defensiveness that we did around missing or null altitudes, we have to do for ground speeds. co-pilot. Thank you. That's exactly what we want. Okay, let's try that. I'm running in release or compiling in release mode to optimize, just because it's a pretty big file. 82 meg. Oh wait, that's something else. That's some other data I've got. 220 meg. So it's running right now. It's using quite a bit of CPU there. You can see most of my CPU's OBS. And my webcam, I think. Well, I didn't expect it to take this long. What's going on? Altitude, ground speed, and then, so currently all this code does is, oh, there we go. We're parsing the GeoJSON, getting the coordinates, getting the properties, and putting it in our little custom struct here. We have a hash map, which maps from aircraft ID to a vector of aircraft state, where aircraft state is position, altitude, and speed. So we just parse it and build up that hash map. Okay, so what did this do? I think it did the right thing. I guess at this point now we have a hash map that we have historical state for all aircraft, and I think it's time to actually look for a rejected takeoff. So let's write a function. Sometimes when you're using Copilot, if you can get the right function name, it will infer quite a bit from that. I don't think it's going to know about this, but take a let's call it history. I'm typing stuff that I know is not great because I know Rust Analyzer will make it better. Let's see what Copilot thinks I want to do. I don't know. I don't know what that is. We don't care. For now, let's not even return anything from this function. Okay, Copilot, it's not helping too much. All right, it's looking for a climbing aircraft or something, but so let's see. We're just gonna do. I'm gonna write the dumbest code. There's probably like a one-liner that uses iter utils in some really smart way, but let's just say. Well, okay, so maybe it's a little state machine. Okay. So let's do something really stupid and simple. We'll just look for like three data points where it's accelerating. Speed is increasing. Let's just see what that looks like. This is all wrong, but we'll fix it. Oh, it's laggy. That's the CPU thing. That's what I get for streaming on a Mac. Let me turn off the camera for a bit and see if that helps at least the voice lag. I've seen this happen before, and sometimes it resolves itself. Oops, I don't want that. So if altitude equals 0, exactly, now you can't see anything but my desktop, not my face. There can't be camera lag if there's no camera. Okay, so if altitude is not 0, kind of reset our state. If altitude is 0, yeah, that's right, Copilot, or at least it's good enough. I'm just thinking about, well, let's just give it a try. So if current speed is higher than last speed, increase number of acceleration points. Let's make the threshold 4. Oh, Copilot, you're so optimistic. Sure. Let's do that. And we'll just, for now, let's just return. I mean, theoretically, so this history might include multiple takeoffs for a given aircraft over a couple hours. That's possible, but we're not going to worry about it for now. Okay, and otherwise, well, okay, so actually, if the speed is the same, let's not do anything. If speed decreased, we reset. This is all bad. It's okay. Let's just run it and see. See, I don't really think I had that much. And I knew this was wrong when I wrote it. I'm not a very good Rust programmer. Actually, at lunch today, I was having lunch with some friends who are programmers, and I was like, nothing will make you feel like you don't know how to even write code as fast as trying to stream your live coding. I've been coding, since, I don't know, almost 30 years. But doing this, it's like, I don't know anything. How do I open a file? How do I read a file? I don't know. Part of that is just I'm kind of a Rust beginner. But also, I just I don't memorize a whole lot of stuff. I've got other loftier goals. That's not true. Sometimes it's true. My main goal is just to get something working, even if it's ugly. All right, so we've got this function that might print something. It's going to probably print a whole lot of somethings. Okay, we've read our aircraft history. Yeah, well, hell yeah, Copilot. That's exactly what we want. Iterate over that hash map. Keys are aircraft IDs. Values are the history, the vector of states. And for each one, do not print it, but do call that function. Yeah, I could just do that for now. I do want to iterate on a map's values, so we'll do that. See, a lot of the stuff, it's like, oh, I could look that up. I almost remember what to type, but I know if I type the wrong thing, Rust Analyzer will tell me what the right thing. It's awesome. All right, let's run it. Oh, I just realized one thing that is important is okay, fine. We will return something. I just want to print the aircraft ID, that's all. So now, actually the cool thing would be, well, for now we're just going to print the ID, but, oh, and now we do want this. God damn it. We do need the keys too. Reference there. Okay. I'm going to try turning on the webcam again. Oh look, the lag is gone. Amy's going to come home. She's going to walk through this door. Be like, oh God, you're doing it again. Okay, we found some stuff. Okay, it's not even bother. Well, whatever. Let's actually, sure, let's bother. Like just a really handy way of. Let's look at one of these. Let's look at this one. A handy way of debugging this is to look at it in ADSB Exchange. So we're going to print a URL that'll let us see the path. That'll just be so handy. Okay, so this is currently, this aircraft is not flying, but let's check January 10. There we go. It flew a lot. So now we're going to do something like I have this bug, or I don't know if it's a bug, this behavior of Safari where I cannot edit a URL. Or maybe it's the ADSB Exchange site, I don't know. It's very annoying. I have to create a new tab. Let's see if that URL works. So now we're looking at, this is going to open ADSB Exchange to the aircraft of interest and on the right date and show it's all the flying it did on that date. So that's cool. So that URL looks like this. The date is going to be the same for everything. What did I do wrong? Oh, I don't know why that's there. Nope, don't want that. Oh, I see. Camera's lagging again. Turn it off. I have to remember to hide my secret IRC window before I turn off the camera. I was thinking a little bit about what, well, if I ever finish this one, which I don't think is going to take that much longer, what else I might try to, what other coding I might try to live stream. Oh, okay. I'll return to that later. So let's just take a look at one of these. You know, it is without a timestamp, it's going to be... Okay, anyway. So sure, we found, we basically detected, like, I don't know, takeoffs, taxiing. Oh, let's at least put it, let's finish this out a little more. Let's put in a threshold. Oh my God. Is that my daughter yelling? Okay, maybe not. Yeah, she is. She's yelling, in case you hear it. Interesting. Okay, so now... So we actually don't care yet. So if it just keeps accelerating, we don't care. The issue is... I'm going to have to redo all this, but we just do the really hacky way first. So if it starts to decelerate, if it has been accelerating enough and last speed is more than, say, 50. Let's see that. Let's see if that works. Okay, so now it needs to accelerate for at least 5 points, data points. It needs to have reached at least 50 knots. And then it needs to decelerate just once. Let's see what happens now. This could actually find something. We're going to have to convert those timestamps into something a little more readable very soon, though. Okay, didn't find anything. Shit. Really? But we know it should have found at least one. There should be one in that data. Okay, I'm going to take a 2-minute break. And kindly tell my children that they can't get out of bed or keep yelling. Be right back.
This is where America's peace of mind begins. Around the clock, radar's electronic eyes watch the skies and report what they see to SAGE, defense system of the United States Air Force. Here is a SAGE center on 24-hour alert. At its heart is a computer developed by a research team from MIT and IBM working with the Air Force. The SAGE computer speeds the information for decisions by man in our missile age. Every scheduled flight across American frontiers is recorded ahead of time on IBM punch cards, then fed into the SAGE computer. Now the computer can draw a picture of what is supposed to be in the sky at any moment. It continually compares this expected picture with the real picture as seen by radar. If a flying object does not belong, it appears on this viewing screen. There's one now at the right of the screen. They call
Marlo just wanted a teeny drink. That was easy to deal with. Okay, so now I'm trying to figure out why this really simple set of criteria that I thought should have just resulted in a lot of false positives didn't even find the one rejected takeoff that we know exists. So 1, 2, oh shit. Well, 3 knots, 7 knots, 8, 60. You know, I forgot to look up the ID of this United Airlines jet. That would be handy, because I'm not positive these points map to I'm not sure these are the only data points in the history, but 1, 2, 3. So this is 3 accelerations. Oh, okay, fine. Let's change the right. 1, 2, 3. So it's got to be more than, well, okay. It's got to be at least 3. And we'll add a little constant for ground speed. Minimum threshold we need 50. That should be okay. Acceleration threshold. Let's rename it. Is that the only place that appeared? Yep. Ground speed threshold. It's not a unsigned int. It's a float. Oh, and it's got to be more than or equal to. Because we only had might have only had 3 in that data. Three seems pretty good though. It actually takes a while to run this. Dare I parallelize it? That'd be very ambitious. It would take me 100 times as long as the time I would save by doing it. It takes a long time just to read all those positions. And not as long to actually process them, but it still didn't freaking find that one rejected takeoff we know is there. This is the problem with having this hacky little state machiney thing. It's a little hard to debug when you've just got like millions of points. So I'm just reading through it just to see what dumb mistake I made. Oh, well, I didn't mean to, didn't actually, oh no, that's if it's, oh, what happens if, what if that wasn't the first flight of that aircraft? What's that? It takes off, altitude is not 0, we just reset this. And we wait until altitude is 0, so that should work. We reset last ground speed, so that works. Oh. Oh, jeez. set that, right? I mean, maybe I should do that. There. Well, no, not there. But so if it's on the ground, we always update last ground speed. Yeah, it doesn't quite work there. Might have to copy it a few places. Okay, maybe that's all we need. But wait, so if I mean, actually, I think we don't want to make it, we don't want to reset speed to 0 there. We just want to set it to whatever it is. Yeah, let's try that. State. Program state is the mind killer. Looks like the camera's holding up okay this time, no lag. Here we go, we got some. Let's just look at one. ADSB Exchange, if you don't know, this is a great flight tracking site. The cool thing about it is they don't censor any of the data. So we printed out the state. Oh, I forgot to save the timestamp. That's kind of important. All right, fine, we'll deal with timestamps now. So looking at this, it'd be nice to know when it thought this happened. It's probably taking off from Moon Bay Airport. There's when it happened. It looks like this aircraft maybe only, oh no, it did some other stuff over here. Yeah, anyway, we are going to need the timestamps, so let's do that. God, timestamps. Oh yeah. So my way of programming a lot of the time is, look up how did I do that in the last program I wrote, because I certainly didn't memorize it. So this is another little bot. I'm kind of working on a collision avoidance alert bot. Yeah, we'll need chrono. So that's fine. We'll just do that. Oh. Webcam is lagging. That sucks. Someday I'll remember to hide the IRC window first. Oops. And all my CPU is being used anyway. There we go. My whole computer is laggy right now. There we go. On chrono. Use chrono prelude. Then to parse a timestamp. The timestamp in this data. These are seconds. Actually, yeah, so use a date time, UTC. And we got to parse that in. hope that these all have timestamps. Oops. Yeah, that's pretty much what we want. Except, let's just do... Okay, so we got the seconds. Come on, Copilot. Is that really what it is? UTC.timestamp. Okay, sure. We can do that. If it wants an I-64, it gets an I-64. Okay. All right, I think we have timestamps. So now when we run this, we'll be able to see roughly when it thinks this event occurred. Meanwhile, let's close a couple windows. I feel like we're actually weirdly close to this doing the right thing. Just moving the camera, I feel like I'm always on the left side of my screen. Oh, but I'm not showing the camera anyway. Oh, really? Okay. We just have to be defensive about the timestamp too. It panicked because there was no... Oh. Well, okay. That's a Copilot fail. It thought it was going to be time. Right? TS, yeah. I don't think I wrote that. I think Copilot did. Okay. Let's take a look at one. So that one is for this aircraft, 2152 Zulu. Oh. This is a fun one. So first of all, so this is a TISB contact. This is an aircraft that was not broadcasting its own GPS coordinates, but air traffic control injected it into the ADS-B system as a synthetic target for safety so that other aircraft would see it. It took off from... Maybe it's not military. I thought it was military just because a lot of them come up from this area and follow the coast like that. It's a helicopter because it's going kind of slow. Anyway, 2152 Zulu. So this happened over here. Okay, so it's interesting. This data is just not that super clean, right? This aircraft was not really on the beach at 0 feet, 100 knots. It just wasn't, so. But I think it kind of worked, right? Let's see, it accelerated 99, 104, 52, accelerated 99, 101. 105, 106, and then it slowed down. Okay, that's what we told the code to do. It's just that this data is not good. Well, let's just look at another one. We'll think about how to filter stuff like that out later. Let my brain percolate on that a little bit. So here's another one. I mean, one possibility is we folded a reported altitude. Well, there's a ground switch, so the data actually for altitude is either a flag that it's on the ground or it's a number, and we kind of just took the thing where if it says it's on the ground, we made it 0, but we might have to change that. What do we have here? This is an ADSB contact. Maybe the data will be better, and the IKO is A36. So we were just looking at this one, and that happened at 017 Zulu, which this is, I think this is a helicopter charter company, Island Express. I won't say more because I can't remember for sure, but if you look them up, you might find some interesting stuff. So is it 0017 Zulu? Yeah. It's really, what is this thing doing? Of course, we're going to find every weird ass aircraft doing like the weirdest stuff is going to trigger this now. So where was it at? 0017 Zulu. It's flying up. Oh. What was it doing at all? I wonder if it was servicing one of the Thumbs Islands. The oil wells just off the coast. I can't even tell because the track is too dense. Helicopters are going to give you false positives here. Well, I mean, hopefully the altitude thing should. Yeah, I mean, maybe they will. The altitude bit might help. Well, oh yeah. Okay, so you can see here. There's some altitudes that might shock you. Minus 50 feet, minus 75 feet, minus 100 feet, minus 150 feet. Altitude reported by these aircraft is a little bit of a fiction. So they have to calibrate the altimeter to the current barometric pressure. And that changes all the time, and it's different in different places. So, I mean, also, I'm not a pilot, so I'll probably say things that are totally wrong, but that's kind of my understanding. So you can totally have a minus 100 feet. It just means, you know, the dial needs to be clicked a little bit inside the cockpit. Whether they're using some old data or they're just using the data they were given about what the current pressure is. ADSB reports 2 different altitudes, barometric altitude and GPS altitude. GPS altitude can actually be more accurate. In this case, we just have barometric though. Yeah, maybe we have to do the ground thing. Well, let's look at another one. I mean, so far these have been kind of interesting. So this is AE5. This is at 010 Zulu. I kind of want to save that tab and just try to figure out what that helicopter was doing. This is a military helicopter. Military Black Hawk. Dog 85. And this gets into the other issue that you brought up the other night. Touch and goes. Are going to be false positives for this. So that kind of looks like that's what happened here. We'll say yeah. Let's check this one, 2105 Zulu. Oh, Safari, you're so slow. I love you, but well, yeah, we're also gonna find everyone with bad equipment. So this thing is reporting that it's on the ground switch. So this isn't just you know, the altimeter is not calibrated correctly. The ground switch is on. It thinks it's on the ground, thinks the wheels are on the ground, and that's what it's reporting out via ADSB. So we're just gonna have to live with some of that, I think. And is that what happened, I assume, with this one? 2105. I was flying north to south. Oh, actually, it wasn't quite in that part of the track. It was... Oh, yeah, it was maybe just... just as it was taking off, maybe. God, is this where I just give up and say, well, it's too hard. Let's look at one more. Let's see, 2222 Zulu. I mean, I guess for a touch and go, it's like we want to look into the future. We want all the criteria we have, plus maybe add, and its altitude wasn't above 0 in the next, 2 minutes or 5 minutes. Could work. Do I have to close some tabs? My God. Or use Chrome? Okay. Chrome is doing better. What's the timestamp? 2222. Okay, it's another case where it's reporting a 0 or below altitude, but it isn't really. Okay, so maybe we have to. Oh, well, maybe we need to filter on. It's near an airport. That's totally doable. It's totally doable. Here's how we do it. Remember, you might have seen sometime in the past year or two. Map of airport. So someone did a visualization. It's sort of showing it was like a map of the United States or maybe the world. And it was just a map that showed runway headings. And so what that let you do is see kind of the prevailing winds and how they change in different parts of the country and the world. Because the runways are oriented to take advantage of the wind, so you take off into the wind versus have like a big crosswind. How do I Google for this though? Map visualization, prevailing winds, runway headings. This might be it. I feel like yeah, that's it. So that's cool. But where did they get their data? About runways, headings, and locations. I feel like I was looking at this before and found info. Oh, wait. Data sources. Here we go. I'm switching to Chrome. rairports.com/data. Yes, I remember this now. Runways.csv. I think I downloaded this already. Yes. So we have every runway, coordinates, heading. So let's add another filter. Where you have to be close to an airport, at least close to a runway. Okay. This might be a good time to stop. Didn't get as much done as I was hoping, but we did actually process histories and find some weird stuff. Found all the kind of weird edge cases in the data that, you know, kind of makes sense as far as that they would trigger this. It's just that it's kind of dirty, weird data that we have to be smarter about our criteria because, well, I mean, it's like the simple criteria should work if it was ideal data, but it's not. So we have to add some more intelligence. I think that using runway information, that will take care of this. That will take care of the issue where a plane is just, you know, flying around and the ground switch is stuck. That it won't fix the touch and go issue. So we'll have to do something else about that. But I think that is a problem for another night. Didn't write a whole lot of code, unfortunately. One janky function. But I think that's okay. Yeah, let me just think about this a little bit. So we